We're going to talk about the density of an ideal gas. The four properties of an ideal gas can be related in the ideal gas law, which is PV equals nRT, where P is pressure, V is volume, N is the moles of gas, R is the universal gas constant, and T is temperature. The units of the four properties have to cancel out with the units of the universal gas constant. However, these are the common units used. The density formula of an ideal gas can be derived from the ideal gas law, where D equals M times P over RT. D is density, M is the molar mass, P is pressure, R is the universal gas constant, and T is temperature. And the common units for these factors are listed. Let's take a look at an example. What mass of argon gas is required to fill a 20.4 liter container to a pressure of 1.09 atmosphere at 25 degrees Celsius? We always want to start off with our given. They're asking for mass, and I want to remind myself that mass is in grams. They gave us volume, pressure, temperature, and I'm going to go ahead and list the universal gas constant. I take a look at my units and I see that temperature is in Celsius and it needs to be in Kelvin. So I'm going to add 273 to my Celsius temperature to give me my Kelvin temperature. Now I have all my units, all my factors in the correct units. I can go ahead and plug into the ideal gas law, which is PV equals nRT. I'm going to plug in the numbers I do have. And I'm going to solve for N. N equals 0.909, and I'm going to write out the whole unit, 0.909 moles of argon. I want to make sure that I'm not confusing my information. So we just solved for moles of argon, but they're asking for mass in grams. So I'm going to have to convert 0.909 moles of argon to grams of argon. I always start off with my given. If moles of argon is in the numerator, then moles of argon needs to go in the denominator. I'll take a look at the periodic table and I see that 1 mole of argon is equal to 39.95 grams of argon. Moles of argon cancel out. I'm left with grams. So my final answer is 36.3 grams of argon. Let's take a look at another example. What is the density of nitrogen gas at 248 torr and 18 degrees Celsius? I always want to start off with my given. They are asking for density. They're giving us pressure and temperature. And since they're asking for density, I'm going to go ahead and calculate the molar mass of nitrogen gas. Nitrogen gas is made up of 2 atoms of nitrogen. So I'm going to take a look at the periodic table and calculate that the molar mass is equal to 28.02 grams per mole. I'm going to also list the universal gas constant. Now I'm going to take a look at my units and I see that pressure is in torr, but I need to have it in atmosphere so that it can cancel out with the universal gas constant. So if torr is in the numerator, then torr in the denominator. 1 atmosphere is equal to 760 torr. Also, temperatures in Celsius. It needs to be in Kelvin so it can cancel out with the units of universal gas constant. So I'm going to add 273 to my Celsius temperature and I'm going to get 291 Kelvin. All of my units are correct, so now I can plug into the density formula of an ideal gas. D equals M times P over RT. So density equals 0.383 grams per liter. Let's take a look at another example. What is the identity of an unknown gas with a density of 0.275 grams per liter that exerts 0.216 atmosphere of pressure at 382 Kelvin? I'm going to always start off with my given. They gave us density. They gave us pressure. They gave us temperature. And I'm going to list the universal gas constant. Since they gave us density, I'm going to go ahead and use the density formula for an ideal gas, which is D equals M times P over RT. I'm going to plug in the numbers I do have. And solve for M. M equals 39.9 grams per mole. But they're asking us for the identity of this gas. We solved for the molar mass, so we can take a look at the periodic table and see what number this relates to. If we take a look at argon on the periodic table, argon is 39.95 grams per mole, so that's pretty close to what we solved for. So the identity of this gas is argon. Good luck and keep practicing.